So I'm one of two theme leads for the Centre for Energy on security and resilience. I share the responsibility with my colleague Zoya, who is on leave at the moment, but she's provided a couple of slides for the areas that she is responsible for. So this talk is going to be kind of an overview of some of the activities going on under the umbrella of security and resilience. So I'm going to basically show what the sub-themes within security and resilience are and explain how they kind of link together and what the different challenges within those is. I'm going to look at a few example projects, one of which I've linked to each of the themes, but you'll probably notice that actually each project kind of touches on at least two, maybe all three of the themes we're looking at. And then I'm going to identify some key challenges, and which is partly an invitation to others to come and kind of try and collaborate and do work with us. Because I think a lot of the challenges we're looking at require quite an interdisciplinary and kind of diverse approach. And yeah, for me as well, it's just a bit about getting a bit of visibility about the security and resilience sub-theme. So yeah, we've got three sub-themes within security and resilience. So the first one is systems infrastructure. So this is very broad. It covers all kinds of energy infrastructure. So as Tom mentioned, my background is primarily in electrical networks, but I'm also interested in electricity generation. I'm interested in gas networks. I'm potentially interested in future hydrogen networks or heat networks, or the links between energy networks and things like transport and end use of energy. And really the challenges we have here are, well, the main challenge of energy infrastructure always is there going to be enough energy delivered to meet the demand for energy from the customers? And there are issues with making sure that happens in a kind of, is there literally enough energy of that type being produced? So for example, are there enough power stations? Is there enough gas being imported? In the future, is there enough hydrogen being produced? Is there enough heat available? Then the next thing is that infrastructure resilient to external and internal threats. So external threats might be stuff like cyber attacks or severe weather events from climate change or weird demand patterns. So I think probably when the football's on later, we'll get some very weird electricity demand behavior, but that's something that is kind of quite well understood and reasonably easily dealt with. And then internal threats would be things like the way the system is changing. So we're currently moving from an energy system that has a lot of kind of large centralized energy sources into one which is much more distributed, and the energy sources are becoming less predictable. So if we move from, for example, coal and gas power stations to wind and solar generation, that presents challenges for security and resilience. And then we have to be able to understand, quantify, and improve security of supply in future energy systems. So a lot of the methods that people use to quantify what the security of supply in an energy system is kind of relies on modeling the reliability of different stuff. So in a conventional energy system, basically you've got the two variables are, have my power stations failed and are people using loads of energy? And generally stuff like failures are mostly independent of each other. Whereas in a future energy system, you might be more reliant on being generation from wind or energy stored in some store somewhere, and potentially they're a lot more correlated with each other. I mean, you do get examples, I suppose, of correlated failures. So the kind of horrendous events in Texas earlier this year are an example of systems infrastructure that was not resilient to a particular external threat and that failed. The next theme is digital innovation. So this is characterized by the 4 Ds, so decarbonisation, decentralization, digitization, and democratization. And there are a few different specific challenges here that we're interested in. So the first one is that energy systems can produce an absolutely colossal amount of data, and it's how do we kind of manage, process, and make sense of that and do something useful with it. The next is that we are rapidly going to have a system where we can take millions of different control actions. So how do we figure out the best way to do that? How do we, to what extent do we try and control things centrally? To what extent do we let things be controlled in a distributed way and kind of allow different parts of the system to control themselves and trust them to deliver the outcomes that we want for the whole system through kind of cooperation. And then the other thing is, unfortunately, vulnerability to cyber threats. So as we make energy systems more digital and more smart and more reliant on communication, they become vulnerable to malicious attacks, which can, best case scenario, result in some kind of theft of data or minor disconnection. Worst case scenario, you could bring down almost the whole system. I think there's an example of that having happened in Ukraine a few years ago. And then the third issue is sustainability. So sustainability is a technical issue, but it's also an economic and a societal one. We know that having the energy system transition from the way it kind of was 10 years ago to something that's very different, something that's not producing loads of CO2 emissions, is key to making the whole economy operate in net zero. But we can also view sustainability, I think, as kind of a secure and resilient supply, but perpetually. So we could make a secure energy supply by having loads of gas and oil, but then when that runs out, we've not got a secure energy supply anymore. But if we have a sustainable and secure energy supply, then we're not going to have to worry about security of supply kind of in the long term. So there are two key challenges that we're trying to address here. So the first one is making the best and the most use of sustainable resources. So if we've got generation of energy coming from renewable sources, we want to be able to use that when it's available. Or if we can't use it when it's available, then can we give it to someone else to use? Can we store it for later use? And then the other question is, can we avoid building new infrastructure? So for example, if we're going to transition a lot of things that currently use fossil fuels onto the electricity system, because that's the way to make them zero emissions, then the kind of fear with that is that we'll have to build loads more electricity infrastructure. So we might need to build loads more wires and transformers to transmit the energy. We might have to build more power stations to use when it isn't windy. How can we avoid doing that? Are there other things we can do by relying on the previous two themes, really, making the system smarter and more aware of itself, looking at novel infrastructure solutions to allow ourselves to have the levels of kind of reliability and secure energy, but without costing loads of money, and also without having the significant carbon footprint that building new infrastructure brings. So now I'm just going to go quickly through a few examples of some research. This is not at all exhaustive. So if you go to the Centre for Energy website under the resilience theme, you'll see a big list of projects. Also, I'm sure that list isn't exhaustive either. So if you're doing research on energy in the area of security and resilience, any of the topics I've covered, please get in touch with me and we can look at how to see if we can work together within this theme and also promote your research through that website and other means. So the first bit of work I'm going to talk about is security of supply in future energy systems. And this is specifically looking at national level, how do we make sure there's enough electricity available, particularly if we're going to move heating from gas into electric heat pumps. And particularly as well, if we've got climate change affecting that, so affecting both the amount of renewable generation we've got and affecting the amount of heating we need. So in Great Britain and a lot of other countries, the peak electricity demand is in the winter, and we need to have enough energy available to meet that demand. But at the moment, most of the heating demand, which is very seasonal, is met by gas. As that moves to electricity, how much more electricity are we going to require during those peak periods? And how sensitive is that to climate change? So this is some work that we're doing in collaboration with energy meteorologists at Reading University. So we've got expertise over here in the energy systems, and they've got expertise in modeling future weather and climate, and then mapping that onto data that we can use directly in the energy system. And this is a very complicated figure, so I'm not going to talk about it too much. Basically, on the x-axis, we see how much extra generation we would need for different historical years based on an amount of wind generation and an amount of heat pump uptake, which we think is going to be the case in about 4 years' time. So what we see is for some winters, so this winter of 2010-11, which is the first year after I started my PhD, was incredibly cold, but it also was, so the color of these bars shows how cold it was. So if they're dark blue, that means it was on average, that winter was 1.5 degrees less than the average winter. So that was an incredibly cold winter. But what we also see is that some quite cold winters, so the winter of 2017-18, actually we would have needed less electricity, kind of spare power station capacity. So this is the amount of additional power stations we'd need to make the demand secure. And this is because some of these cold winters also happen to have, they happen to be windy. But unfortunately, you can see in general, yeah, the colder winters are those which are also needing more of this additional generation capacity. So this was looking just at Great Britain. So the question we had next, and what we're working on now, again with Reading, is what about our interconnection to all these other countries? So is it cold and not windy in Great Britain at the same time it's cold and not windy in Ireland, France, Belgium, the Netherlands, all these other countries? So what we're looking at is whether these interconnections can effectively take up the role of extra power stations so we don't have to build any. So we're building these extra interconnections anyway, mostly to allow us to move around excess renewable generation. So this is, can we use something which we're building for kind of economic and sustainability reasons for security and resilience as well. The next topic, so this is the theme that is led by Zoya, the digital innovation. So I probably can't answer any questions on this in great detail, but basically in this area, the Centre of Energy is studying different ways to categorize and mitigate cyber threats in smart energy systems. Particularly, they've looked at cybersecurity challenges in EV charging infrastructure, investigated the cybersecurity analysis of smart grid communication protocols. So that's things like how is cybersecurity dealt with in standards like IEC 61850, I think. And then in the autumn this year, there'll be an energy systems digitalization conference, workshop, like a conference on cybersecurity. They've also provided technical consultation to the government to inform policy on cybersecurity for smart electric vehicle charging, and have contributed to the development of various standards. So if anyone has any questions about this, get in touch with me and I can pass you on to Zoya to give you more information. The last thing I want to talk about is the idea of integrated local energy systems as something that can help with sustainability. So often in a local area, we're going to get extra electricity demand due to electrification of heat and transport. We're also going to have extra electricity generation at local levels because in a lot of cases, renewable generation can be connected much closer to where the load is. But what that might result in is having to build more infrastructure so that we can import more electricity during the peak and then export more electricity during periods of high generation. And the idea is that if we build a local energy system, we can coordinate these resources to make sure that the energy is kind of consumed locally, and we can get rid of the need to build new infrastructure. And I think these kind of integrated local energy systems bring together all the topics in the Centre for Energy, actually, because by using this energy locally, quite often we're able to make this, we could make this more secure against failures, because we'll get we can basically supply all the energy locally. So if there's a lack of supply from elsewhere, we're not vulnerable to it. We're more sustainable because we're making better use of all of these local renewable resources, and we are looking at doing this through a lot of control and monitoring and potentially smart devices and stuff. So we're both taking advantage of and using the large amounts of energy data, but we're also potentially making the system vulnerable to cyber threats, and something we need to be aware of. And if this is a project that I lead for Newcastle called Merlon, which you can go and look at, and we're demonstrating this in 2 sites. So I'm aware I've not got much time, so I'm just going to quickly say I've tried to make this Venn diagram with some of the different challenges. I've said, is this a complete list? I think it's definitely not, but just broadly, I looked at some things which I think are kind of individually in some of the themes and some which are shared between all of them. I think the biggest thing is this climate adaptation, which I think is going to require us to work across all of these themes, and indeed with probably the other themes in the Centre for Energy as well. So to conclude, security and resilience are key challenges in energy. We've got a lot of active projects in this area, but all of these are interdisciplinary challenges, so we need to work together to deal with them. And we need these supplies to be secure and resilient in the long term. So that means sustainability has to be kind of at the heart of making these energy systems secure and resilient. I think there's lots of opportunities for new collaboration here. So please, feel free to get in touch with me or Zoya or anyone at the Centre for Energy if that's of interest. Okay, thank you very much.
Thank you very much, David. I think we have one question from the chat. Catherine says, in the project on the security of supply in future energy systems, did you consider or include storage?
Yeah, so in the figure that I showed from the published paper, we broadly didn't consider storage because that was looking at the energy system kind of as it is now, and so the amount of storage is quite small. I think the storage there is the kind of the larger scale storage, like the pumped hydroelectric, is modeled as basically being a generator. In the project we're doing now around the interconnectors, we are going to include some storage. We're just deciding exactly how much to include and how to model it in some scenario analysis we're doing.
Are there any other questions from the chat? If not, I have a question. It's probably a bit of a stupid one, but in the graph where you showed us the different winters and how much excess or not excess you would need of heat pumps, did you consider the fact that winter seems to be transitioning a bit and happening a bit earlier, a bit later of the year? The Beast from the East being a good example. That was almost March by the time it finished. Was that included in those statistics?
Yes and no. So I think the winter is the same length in all of those years, but we've cast our net for winter quite broad. So it does include, for example, the Beast from the East, and the Beast from the East year was in there. And actually, so in the project we're doing now, one of the things we're going to look at is, basically the method that the meteorologists are going to use allows them to essentially take the events that we've seen in the past, so stuff like the Beast from the East, and then apply climate change signals to that. So we'll be able to see, would the Beast from the East be more or less severe if we have 2040 levels of climate change as the model predicts it? Or would there be other events that become more severe that are more, in the past were maybe not that bad?